Hey everybody, it's Jenny from Norman S. Wright and NSW PEP, and welcome to NSW PEP Talks. In last week's video, I talked about how AI was going to change data center power and thermal design, and so I want to go into a little more detail on that this week and talk about liquid cooling. So let's get started. So what is liquid cooling? As the name implies, it is using water to cool the data center equipment instead of air. We'll come back to air cooling at a later date, but liquid cooling is hot right now, so let's talk about it. I mentioned in the last video that you can transfer as much heat in a 1-inch pipe as you can in an 18 by 18 inch ductwork because water is about 3,500 times more effective at heat transfer than air is. And since AI uses significantly more computing power than a regular search uses, being able to provide more cooling fast and efficiently is pretty important. So let's move this over. There are 3 types of liquid cooling. We'll start with rear door heat exchangers. Although rear door heat exchangers are not technically true liquid cooling, they're often used with high-density cooling systems and are generally thrown into the same category. Rear door heat exchangers are attached to the back of server racks and use chilled water to capture the heat as it exits the racks. These systems can be used with air cooling systems. Let's go ahead and slide this up now to make more room. Next, we have direct-to-chip or cold plate cooling. This is the most common type of liquid cooling, and when most people say liquid cooling, this is what they're talking about. With direct-to-chip cooling, metal plates filled with coolant are attached to the chips, drawing heat away from the chip directly. This can remove about 70 to 75% of the heat generated by the equipment in the rack, which leaves the remaining 25 to 30% to be removed by air cooling systems. Let's slide this up one more time. And then there's immersion cooling. With immersion cooling, servers are submerged in a non-conductive coolant, allowing the entire server to be in contact with the coolant. This allows heat to be transferred from all sides. This maximizes the thermal transfer properties of liquid and is the most energy efficient form of liquid cooling. Now let's slide this over again. Some new liquid cooling data centers are being designed right now, and some new air-cooled data centers are being designed to be AI-ready and accommodate liquid-cooled racks in the future. But there's already a lot of data centers already built, so the most common scenario we see today is integrating liquid cooling into existing air-cooled facilities that don't have the infrastructure to support liquid cooling. So let's move this up and look at some things that need to be considered. One thing to consider is the type of fluid used and the heat load to liquid ratio. Higher heat load to liquid ratios reduce the demand on air cooling infrastructure. Another consideration is plumbing. The piping that carries the cooling fluid to the rack can be challenging to install in an existing facility. Another consideration is the distribution of the water. The key component in the water loop is the coolant distribution unit, the CDU. This provides temperature and flow rate control and the ability to maintain liquid hygiene by using filtration to capture debris in the water. Let's make room again. Another concern is risk of leaks. There are risks associated with moving liquid to the rack and the risk of damage to the equipment, so this is where leak detection will come in. And then you have heat rejection in relation to the specific requirements of the liquid cooling system. Basically, can the existing heat rejection equipment in the data center be modified to maintain the low supply temperatures of the liquid cooling system? So let's bring all this back on screen. And I laid that out kind of poorly, so let's take this section and we'll move it over here so I can make it a little bit bigger. So that's an intro into the types of liquid cooling and some of the things you need to know if you're looking at putting liquid cooling into an existing data center that is air-cooled. We'll go into more detail on each of these topics in the next few videos. Don't forget to like and subscribe to our YouTube channel. Thanks for watching.